Okay, now we're going to look at writing the formulas using the polyatomic ions on reference table E. Just like before, you list your positive first and your negative second. Up until this point, it's been a metal first and a non-metal second. But some of our polyatomic ions are positive without containing metals, and some are negative, also including metals within them. So the more general approach is to list the cation, or the positive ion, first, followed by the anion, which is the negative ion. If you do it in the wrong order, you will be marked incorrect. You have to crisscross your charges. Crisscrossing, just like before, involves taking the charge from one and dropping it down to the subscript for the opposite ion. The catch here is that if you have more than one polyatomic ion inside your compound, whether it's two, one of them being plus, one being minus, or if you find with your crisscrossing you need two of the negative polyatomic ions to balance out the formula, you have to use parentheses. The parentheses are what's going to say we have two or three sets of this polyatomic ion. If you don't use the parentheses, you're very, very likely to start to change the subscripts by accident. If you can simplify the number of ions involved, you absolutely should, but you will never, and I'm going to emphasize this a lot, never, ever, ever change anything about the polyatomic ion, including the subscripts that are inside of it. We are not trying to simplify the subscripts that are part of something like dichromate. That's going to stay in the exact same formula you find on table E. We don't simplify oxalate, which is C2O4. That doesn't get changed. But we can simplify the number of oxalates we have if it happens to match up with the number of the positive ions. Our first example will be ammonium oxide. Ammonium is on table E. Okay, if you look at your first part of the name and you don't recognize it from the periodic table, you should be looking at table E. Ammonium is NH4 with a +1 charge. Oxide is your regular oxygen with a -2. When you go to crisscross these, the 2 is coming down outside the ammonium. Notice how it ends up outside parentheses. That's really important because otherwise you'd be saying we have 2 hydrogens, or maybe even 8 hydrogens if you just multiplied, and that 2 would not be carrying through over to the nitrogen. The oxygen is going to get the 1 crisscross down from the ammonium. Over on the second example with calcium phosphate, we have calcium from our periodic table, which is +2, and phosphate, which is our anion, our negative ion from table E. Its formula is PO4, and overall it has a -3 charge. When we go to simplify after our crisscrossing, we get Ca3 and PO4, 2. Notice how PO4, our phosphate, stays inside the parentheses. If it will be helpful to you to use parentheses every time you write these, feel free, and if you end up writing a 1 outside of it, you can erase the parentheses. But if you don't put them there in the beginning, you're very likely to make mistakes.